Hello everyone, welcome back to Palle AI. In a previous video, I've explained what is artificial intelligence, what is machine learning, what is deep learning, and how they're all connected. In that video, I've explained how deep learning is nothing but a subfield of machine learning. And just like standard or traditional machine learning algorithms, deep learning also maps input X with labels Y, particularly for supervised learning type of problems. If you have not checked that video, I'm going to drop a link below. Please check out that video to understand what exactly AI is, what is machine learning, what is deep learning, and how they're all connected on a very high level. In this video, I want to go a little bit deeper. I want to explain the intuition behind traditional or standard machine learning algorithm. The idea is, if we understand the intuition behind a traditional machine learning algorithm, it becomes that much more easy to understand the intuition behind deep learning algorithm, which is basically the face of modern day AI. The intuition behind deep learning algorithm, I'm going to explain in a later video. But for now, let's jump into the video to understand the intuition behind traditional machine learning algorithm. So for understanding the intuition behind traditional machine learning algorithms, again, let's go with a supervised learning type of problem. So let's say we want to build a binary classification model that can detect human faces in different images, whether human face is present or not. Okay, so we're going to start with again the data that which we're going to use to train the model. So what is the input data in this case for this kind of a problem? So input data would be the raw images. So in this scenario, let's say we have many different images, some belonging to humans, human faces, and some other images. It could be animals or objects, or it could be anything. So correspondingly, what would be our label or answer? So either a human face is present in an image or not. If it is there, we call it yes. If not, it's no. Okay, so this is the training data we have. This is the input data. Okay, the raw images, grayscale images, which we call X, and the labels, which indicate whether this image belongs to a human face or not, and that's our Y. Okay, so we're going to use this input data, and let's say we're going to build a traditional machine learning algorithm. So when I say traditional machine learning algorithm, it could be something like logistic regression, or it could also be a neural network, but very simple neural network with no hidden layers, no intermediate layers, just the input layer and output layer. Okay, all right. So what we're going to do is now, let's look closely at a single image. Okay, so what is a single image in this case, the raw image? It's nothing but a grayscale image. Okay, so when we say grayscale image, what is inside an image? It's nothing but pixel values, right? So in this case, this is a 28 by 28 pixels, total 784 pixels. So that's a single image. Okay, so this image, again, what is the label? This belongs to a human, so we're going to say it as yes. Now, when it comes to machine learning, majority of the machine learning algorithms, they love to work with numbers. They need numbers. So the input data is an image, but again, image is nothing but pixels. So we already have the numbers, right, for the input image. For the X, it's nothing but 28 by 28. It's just 784 pixels. The label is, we say yes, because it's a human face. We can encode that as 1 or 0. So 1 meaning human face is present, 0 meaning human face is absent. So in this case, we're going to convert the yes as 1. So we're just looking at the first image. So next I'm going to show you how we're going to use this first image and build intuition into how machine learning algorithm works. Okay, so we're going to start with that first image, and we're going to take that 784 pixels and we're going to flatten it. Basically the 2D image, right, 28 by 28 pixels, we're going to convert it into a 1D pixels. Okay, so total 784 pixels. That's our input. That 784 pixels belong to that image of the human face which you're seeing there. Okay, so we take this image, and this image has a human face in it. So what is the Y for this? The actual Y, it's 1, right? Because 1 means human face is present, 0 means human face is not present. So the goal of machine learning algorithm now is take this input image, the grayscale image, and use that pixel values, the 784 pixels, and map it to the correct label that in this case it is 1, meaning that it belongs to a human face. When I say map, what is mapping? Mapping, as I alluded earlier, it's coming up with a formula or a relationship or an equation, and it could be something that looks like this: ypred equal to some function of a linear relationship between the input variables here. And as you can see here, this ypred is calculated using some coefficients or parameters called W1, W2, W784, which I called earlier in the previous videos as weights. So the goal is to come up with an equation or a formula that can predict y using the input values and a optimal choice of weights or parameters or coefficients. Let's take a closer look at these weights. As you can see, there are in total 785 weights, W1, W2, W3 up to W784 and B. So you might be asking, why is this last weight called B instead of another W? If it helps, from high school math, think of B in a straight line equation, think of B like an intercept term. Or think of B as a bias term that will ensure the output of this formula, ypred, is going to be non-zero, even if all the input pixel values are 0. Don't think too much about this B at this stage, if this expression also doesn't help. For now, just think W1 to W784 and the B, these are all weights or trainable parameters that are trying to satisfy this formula, this relationship of predicting y given input pixel values x. Okay. But how are we going to find these weights that will satisfy this relationship? Well, initially, what the machine learning model tries to do is, it will just guess these weights because it doesn't know them. So it is something called random initialization. It randomly initializes some numbers, some values to these weights. Okay? So the model just initializes some random values to these weights, W1 to W784 and B. We already know the input pixel values, X1 to X784, right? We're going to use the input pixel values and we use the randomly guessed weights to calculate the ypred from this equation. Okay? So let's say the output from this equation or the model's prediction is going to be something like 0.1. Now, the image we are looking at right now actually belongs to a human, right? So the actual y or the actual label for this image is 1, meaning it belongs to a human. But because we randomly guess some weights, these are not optimal weights, the W1 to W784 and B. Initially, the model just guessed them. Because it guessed them, the output, you can't expect it to be actually exactly y, right? So it will be something, but it will be far from y. So there will be some divergence between the model's prediction and the actual y. How much is that divergence? So the model tries to compare the output from its prediction and the actual y, like trying to predict or calculate the error. Or in machine learning terminology, this is called loss function. So how does this loss function look like? Well, in a very simple terms, just subtract 1 from 0.1, its absolute value is 0.9, that's the error, 0.9. But in reality, the loss function can take many different forms depending upon the type of the problem which the machine learning is trying to solve. But for now, let's just look at a loss function as some measure of calculating the error or the divergence from between the model's prediction and the actual y. Okay, so this is called forward pass. What we just did was for just one image. We took one image with some guessed weights, right? Using for that image, the pixel values for that image, using the guessed weights, we calculated the ypred output from this formula. And then the model measured the error between the prediction and the actual y. Now the machine learning model or algorithm tries to do this for all the images. Important to remember here is the weights are the same. So you don't use different weights for each image. There are in total 785 weights that tries to satisfy this relationship. Using these initially guessed weights, the 785 weights, for each image, the machine learning algorithm, it's trying to predict the y, and then it tries to compare the prediction with the actual y and calculates the loss or the error for each image. Then it sums up the losses or the errors on each image into something called a cost function. So it sums up all the losses for each image and divides by the total number of images. And we call this as a cost function. So what is this cost function? It's just the sum of losses divided by the total number of. It's like, I think of it like an average loss. You can also think of it like, because we call it cost function, think of it like a cost or a penalty. The model is paying because it just guessed these weights instead of finding the actual weights. So machine learning model doesn't like that, right? It wants to, because the goal of machine learning model, you want to recognize or identify the optimal weights that will satisfy this relationship. When I say satisfy this relationship, what does it mean? It means whatever the weights the model ultimately selects, it should predict y given the input values as close as possible to the actual y. Okay, so what the machine learning model tries to do is, it doesn't want to pay this cost, so it wants to minimize this cost. It wants to take this loss. Again, cost is nothing but the losses associated with each image. Machine learning algorithm wants to minimize this penalty so that it can become smart, right? So it is trying to find those weights that can make this cost function, this j, 0. How do you do that? How do you find these weights? Initially, you guess the weight, so the cost might be high. But how do you find these optimal weights such that this sum of losses or the cost goes to 0? Well, one naive way, think of it like maybe you tweak the weights like manually by hand. Initially, you guess some weights, you calculate the loss for each image, sum up all the losses, see what the total loss is, then tweak the weights a little bit more with hand, guess some other weights, keep guessing. It's a very naive way and it's going to take forever. Fortunately, there is a mathematical way to ensure that this cost function goes to 0 by selecting the optimal weights. And that is called a gradient descent method. And that is typically what an optimizer does in a machine learning or deep learning. So what this optimizer is doing is, it's taking this total loss for all these images, right? And it's trying to adjust the weights, tweak the weights a little bit in such a way that this cost function goes to 0. And the way it does is it uses a technique called gradient descent technique. In a mathematical fashion, it will try to tweak the weights or update the weights such that this cost function goes to 0. So you take the cost function, you adjust the weights. As you can see this equation here, this equation kind of represents a technique called gradient descent method. Okay, so using, we're going to go in detail about what gradient descent is or the loss functions are in more detail in the later slides. But for now, in this video, I want to give you a very high level intuition behind machine learning algorithms. Machine learning model adjusts the weights or tweaks the weights and tries to minimize the cost function j using the gradient descent technique in an iterative fashion. In the first iteration, the cost function j will be very high because we guess the weights in a random fashion. But after the first iteration, using the gradient descent technique and this equation, the weights become a little bit better. The machine learning model then uses this updated weights and calculates the YPRED again. It then compares the updated YPRED value with the actual value and calculates the updated loss function for each image. It will sum up the losses for each of these images and calculates the updated cost for all the images. And then it continues. It will adjust the weights using the gradient descent technique and will calculate YPRED again. All of this in an iterative fashion. And the machine learning model or the algorithm continues this iterative fashion of updating the weights and trying to keep on minimizing the cost until the cost actually goes to 0. So what happens when this cost function goes to as close as possible to 0? Well, at that point, machine learning model or algorithm, it would have been said to have become smart. It would have become learned, meaning it was successful in finding an optimal choice of weights, W1 to W784 and the 785 weights, that will satisfy this relationship perfectly, meaning it can predict Y with a very good accuracy, meaning the predicted Y values will be very close to Y for the given selection of weights. So the learning in machine learning or even in deep learning can be simplified to the choice of finding these optimal weights that can minimize the losses, minimize the cost on a given training data set. Okay, hopefully this has helped you in understanding the intuition behind how a traditional machine learning algorithm works. Next, we're going to look at the intuition in a deep learning algorithm. Some of the concepts here are going to be very similar, especially with respect to the loss function, cost function, and the gradient descent technique. But where deep learning differs from machine learning is in the calculation of some intermediate layers where the input data has been transformed. So we're going to look at that in the next video. Okay, thank you so much for watching this video. Hopefully the explanation I have provided help you in getting a little bit better understanding of the intuition behind a traditional machine learning algorithm. Please let me know in the comment section as to what you think. If you like the video, I would really appreciate if you can please like and share with anyone who is also interested in knowing some of the basic concepts or the fundamentals within the field of AI, machine learning, and deep learning. I would also appreciate if you can please subscribe to this channel so that I can send you the latest content as I create it. For example, in the next video, I'm going to talk about the intuition behind a deep learning algorithm. Thank you so much. Please stay tuned.